Welcome to The Explainer. Today, we're unpacking a fundamental truth of modern technology. Why adding deeper layers to artificial intelligence is literally the engine behind its incredible power. Okay, let's dive right into this. Consider this question for a second. What if the real power of AI comes not from one brain, but from many layers working together? That profound question is really the philosophical core of deep learning. We're shifting away from thinking about a computer as just a single calculating brain, and instead, we're viewing it as a deeply collaborative stack of processes. So, deep learning is all about progressive understanding through many layers between input and output. And I really want to emphasize here that the word deep isn't just some marketing buzzword about massive size or having billions of data points. It is specifically about that space between the input and the output. That space is where the progressive understanding actually happens, step by step. Here is our roadmap for the explainer today. 1. The secret of modern AI. 2. The hierarchy of learning. 3. The deep network roadblock. And 4. Fixing the AI brain. Section 1. The secret of modern AI. The big idea here is that each layer transforms data just a little more. Intelligence doesn't just happen magically all at once in a single flash of computation. It's a gradual, deliberate transformation. Raw input goes in, and then it's steadily molded, changed, and refined layer by layer by layer. Section 2. The hierarchy of learning. And this brilliantly illustrates how it all comes together. Think of AI decision-making kind of like a factory assembly line. You start with step 1, the raw input. But instead of jumping straight to an answer, step 2 transforms that data layer by layer, building understanding until it finally reaches step 3, the final decision. Let's make this tangible by looking at an image recognition example. Imagine a photo going into the system. Layer 1 doesn't just instantly see a dog or a car, right? It just detects very simple patterns like basic edges, colors, and textures. Then layer 2 takes those simple elements and combines them into shapes and parts of objects. By the time we reach layer 3, those shapes are combined again to recognize full objects and entire scenes. You can really see how simple patterns escalate into highly complex ideas. Which brings us to a crucial takeaway. It does not just see pixels. It learns hierarchy. When a deep learning model looks at a photo, it isn't just memorizing a flat grid of colored squares. It's actively constructing a hierarchy of reality, building a deep, structured comprehension of the world around it. And honestly, this layered, step-by-step understanding is exactly why deep learning powers the most impressive tools we use every single day. We're talking about image and speech recognition, those massive language models, and the complex recommendation systems that know exactly what you want to watch next. Section 3, the deep network roadblock. Now, you might be wondering, why not just add a million layers? Well, just throwing more and more layers at a problem isn't a perfect magic trick. Simply adding layers creates a major, unexpected technical flaw known as the vanishing gradient problem. So the crucial point is, this happens when signals used to update earlier layers become very small, causing them to stop learning properly. You see, as a network tries to learn from its errors, it sends a signal backwards. But when a network is very deep, those learning signals literally fade away before they even reach the start. The severity of this roadblock is super obvious when you look at the architecture. The later layers, the ones closer to the final decision, they continue receiving strong signals and keep updating and getting smarter. But those early layers, the signals are simply too weak. They just stop learning. And if your foundational early layers fail to recognize basic edges and colors, the later layers have absolutely nothing to build on, which makes the entire deep network incredibly hard to train. Section 4. Fixing the AI brain. To fix this fading signal threat, engineers invented a clever tool called the activation function. Think of this as the essential gatekeeper inside the network. Its entire job is to decide whether a neuron should pass information forward and exactly how strongly that signal should be pushed along to the next layer. And a specific hero activation function that really rescued deep networks is known as ReLU. ReLU keeps useful signals active and reduces problems in deep networks by preventing those vital learning signals from shrinking and vanishing into thin air. This allows deep networks to finally train effectively from the very first layer all the way down to the last. Let's move to a quick recap and see how this builds a complete system. Early layers learn simple patterns. Middle layers combine them. Later layers grasp complex structures, and the output layer delivers the final decision. Every single part relies seamlessly on the part right before it.
I really want to reiterate this powerful architectural metaphor. It becomes intelligent by stacking transformations. True computational intelligence is built from the ground up, stacking tiny, simple transformations on top of each other until the result looks, frankly, like magic.
Okay, now it's your turn. Try to trace a picture going through this system in your own mind. Imagine layer 1 grabbing the edges, layer 2 forming those into shapes, layer 3 recognizing actual objects, and layer 4 understanding the entire scene. Adding deeper layers is exactly what allows the system to grasp increasingly complex realities. Finally, I'll leave you with this provocative question to chew on. What might go wrong if the network is too deep? Extreme depth introduces a lot of chaos, requiring some pretty brilliant error correction techniques that we will definitely cover in the future. But for today, just remember this. Layers are exactly what turned AI from a simple calculator into the incredibly powerful intelligence we see today. Thanks so much for joining me on this explainer.